Welcome to this little companion to the algebra tiles. It's a little step back, an intro to algebra tiles, as well as diving into a little bit of the distributive property, understanding how the algebra tiles can help students understand the distributive property, reduce that frustration level, actively engage them. We're going to create that positive learning environment again. Keep in mind that we're living in that concrete build it phase right now. Eventually, they'll move to a semi-concrete. They may see this once and then dive right into the semi-concrete by drawing it so that they can have a deeper understanding in the abstract. We're living in those EBPs. Now, we're going to step up and listen to a little bit of a video from Hands to Mind that gives you that intro. So here we are now thinking about how do we use algebra tiles to model and simplify expressions. And then we're going to dive in a little bit on how to then use algebra tiles to model and simplify expressions that involve the distributive property. So here we have an expression. The algebra tiles, remember from that little introduction, if it's red and it's a rectangle, then that is the variable negative x. If it's green, it is a variable, but it's the positive x, so it's 1x. And then the smaller squares that are red and yellow, or as sometimes they consider them like a light tan, are considered the constants. And so in this case, we have 3 yellow, which means that's our constant. So this really this is a model, a visual model for negative 5x plus 2x plus 3. So let's continue watching what happens. If we create 0 pairs, and 0 pairs are when you take a negative value and pair it with a positive value, whether it is an x or an x squared or a constant, it will create what we call, like canceling out, a 0 pair. And so here we have our 2 negative x's with our positive 2 x's. These cancel out and create that 0 pair. And so if we just kind of pull those aside, cover them up, we now have this simplified expression where we have 3 x's that are negative, and we have 3 positive constants. If we cluster those into a group that are exactly the same, we have 3 groups of negative x plus 1. So that's an important transition. So students should be able to see that they can create these other like subgroups. And so that's what's going to be involved in that parentheses. So if we use the distributive property, we'll have negative 3x plus 3. If we keep them grouped, then we can actually have it as 3 parentheses negative x plus 1. And then they have a visual model for the distributive property. That's powerful. Let's look at another one. Now we want to model, then simplify. So here we have 2x plus 1. That's what's inside the parentheses. But how many groups of that do we have? We actually have 2 groups of that. So this is what it looks like. And so if we want to simplify that, we now can see that it's 4x plus 2. Now, if we have another one that we actually extend it, then we can see how this is a little different. This is a powerful model. So this will help build that visual model again so that students can see what happens if we extend that expression. So again, we start with what's inside the parentheses. That is a group of 2x plus 1. And how many groups of that do we have? We have 2 groups of those. Outside of that parentheses is that subtract 3. And so then they can model that using this visual model. And then we create those zero pairs. And now we have it simplified so that we see that this expression really is 4x subtract 1. We can also model additional ones. So I'm just going to go ahead and show the model here. Again, we're starting with negative x and subtract 2. So that's been modeled here using our algebra tiles. That's inside the parentheses. But we have 4 groups of those. So here we are. Now, when we combine all our like terms, we wind up with negative 4x subtract 8. If we, again, extend that expression, we repeat that process. What's inside that parentheses, that is that group of negative x subtract 2. We not only have one of those, we have 4 of those groups. And then we model our addition of 4. That's creating that 0 pairs again, and we can simplify that now to negative 4x minus 4. So this is our little mini, but I wanted to make sure that you see that the distributive property can also be modeled with the algebra tiles. Let's go forth and conquer.